August 15, 1977. At observatory scanning the night sky, the work is largely passive. Massive radio telescopes simply point outward and wait. The process of listening to space in this era didn't involve scientists wearing headphones. The real work fell to massive, automated computer mainframes, methodically recording raw data onto magnetic tape. Most of that data is exactly what you would expect from the vacuum of space. It's a low-level, continuous hum of cosmic static, the ambient noise of the universe. The observatory's automated systems were calibrated to filter out this baseline static. They were searching for specific deviations that stood out against the background. On this particular night, the observatory floor was completely empty. There were no human operators present, leaving these silent machines as our only active witness to the cosmos. Deep into the night, that entirely predictable baseline shattered. A focused, powerful radio wave suddenly struck the telescope's receiver. It was a sustained transmission that held its exact intensity for a strict window of 72 seconds. In the empty room, the unstaffed mainframe reacted exactly as programmed. Its printers jolted to life, rapidly logging the spike in signal strength onto physical paper rolls. And then it stopped. At the 73rd second, the signal vanished entirely, and the familiar background static resumed. The machines had captured a massive departure from the baseline, yet without anyone there to witness it, the anomaly sat buried in a stack of paper. The data sat untouched for several days until astronomer Jerry Ehman arrived to perform a routine review. His job required scanning hundreds of pages of printed characters, hunting for numerical anomalies in endless columns. While scanning, a specific cluster broke every standard pattern, a sequence reading 6EQUJ5. This chart maps that alphanumeric sequence. Numbers 1 through 9, then letters A through Z, represent an exponential curve of signal strength. As it hits U, the line drastically spikes against the flat baseline of cosmic noise. This sequence proved the anomaly was no local glitch. It was the mathematical footprint of an immensely powerful, localized transmission hitting the telescope. Ehman noticed two details. The signal was extremely narrow, and its frequency sat at 1420 MHz. This is the frequency emitted by neutral hydrogen. For decades, scientists speculated an interstellar beacon would use this exact cosmic calling card to stand out. Breaking from sterile protocol, he took out a red pen, circled the sequence, and wrote a single word of astonishment in the margin. Wow! The quiet atmosphere of the observatory shifted to immediate action. Ehman alerted his team, and the physical printout became the center of frantic analysis. They quickly worked to recalibrate the telescope, adjusting the massive dish to aim right back at the exact celestial coordinates where the signal had originated. They expected to pick up the transmission again. Instead, they were met with total silence. The signal was gone, leaving them staring at an immediate scientific dead end. The foundation of modern science relies on repetition. For any discovery to be confirmed as fact, researchers must be able to observe it happening more than once. Over the following months and years, astronomers launched exhaustive, targeted searches of that specific patch of sky, desperate to hear it again. This created a unique frustration. Scientists were left holding a physical record of a powerful transmission, but without a second pulse, the data remained an isolated incident. Without the ability to observe the signal again in real time, strict observational science hit a wall. Researchers had to pivot to theoretical forensics, analyzing the single recording from every possible angle. The WOW signal transitioned from an active discovery into a scientific ghost, a perfect data point with no identifiable physical source. One prominent natural explanation proposes that an unmapped comet passed through the telescope's field of view, releasing a massive cloud of hydrogen gas that caused the sudden radio spike. However, many astronomers dispute this. A comet's emission profile doesn't neatly fit the data, leading some to argue the signal was caused by a rare, completely unknown cosmic phenomenon instead. The most enduring theory looks directly at the signal structure. This visualization compares the broad, messy wave of natural comet emissions on the left to the razor-thin, artificial-looking spike of the WOW signal on the right. The exact duration and concentrated frequency suggest a deliberate transmission from an intelligent alien civilization. After decades of analysis, no single theory, natural or extraterrestrial, has managed to completely explain the data captured in 1977. The WILE signal stands as an unresolved cosmic tension. It is either an impossible natural coincidence or a missed call in the dark. Drop a comment below and let us know which theory you think is correct.